Good day. My name is Solomon Tosin Omitogun. I'll be making a presentation on geotechnical and geophysical investigation and lime stabilizing effect on subgrade failure around the section of Lagos-Abeokuta Highway, Southwest Nigeria. This research was recently conducted as a master's student of the Department of Geosciences, University of Lagos, Nigeria. This is the outline of the presentation from the introduction, study area, and down to the conclusion, as it is being displayed on the slide. Many Nigerian roads fail soon after their construction, long before their estimated lifespan, as a result of factors which include lack of proper soil investigations, bad construction materials usage, lack of proper drainage design, amongst others. Roadway failure often arise as a result of structural defects such as depression, cracks along the road, ruts, and so on. This always leads to high cost of transportation, unplanned maintenance costs, unnecessary delays, and sometimes leads to loss of lives and properties. Soil stabilization have been discovered to significantly improve the strength of subgrade soil by increasing the shear strength and decreasing the swelling capacity, especially soils with high clay content. In the course of this study, the cause of the road failure and the effect of lime on the strength of the subgrade soil were investigated. Over the years, many researchers have carried out work in similar cases of road failure, and it was discovered that some of the reasons why this road failed was as a result of bad geotechnical materials of subgrade soil. Then also proximity to groundwater level could also be part of the reason for such road failing before their time, and also low resistivity values of subgrade soil was discovered, which is tantamount to the presence of clay in such subgrade soil. So the aim of this study is to investigate the roadway subgrade failure along a section of the highway in the study area and to observe the efficacy of lime as subgrade stabilizing agent. The objectives are the electrical resistivity imaging of the subsurface to observe the subgrade lithology, the determination of the geotechnical nature of the subgrade soil by carrying out geotechnical laboratory tests, and also observing the effects of lime as a stabilizing agent. This is the map of the study area showing the geological map of the area. This map was modified after January 2018, and it was shown to be within coastal plain sand formation, and this formation is within Dahomey sedimentary basins of Nigeria. This is the base map of the study area showing the direction of Abeokuta from Lagos with the arrow, and 5 traverses were delineated of 100 meters each. Along each of these traverses, subgrade soil was taken from the depth of 1.4 meter, which were taken to the laboratory for further tests. And along each of these traverses, electrical resistivity surveys were carried out using Wenner and Schlumberger array methods. This is the methodology which typically entails the field study, the laboratory work, and the stabilizing agent replacement. The 2 array methods which were used, as stated earlier, were Wenner array and Schlumberger array. And in Wenner array, the spacing of the electrode that was used was 2 meters, and this small spacing was chosen so as to have a detailed information of the subsurface within the first 10 meters from this ground surface. The Schlumberger was used to carry out vertical electrical sounding about 4 vertical electrical sounding were carried out in each of the traverses, making total of 20 vertical electrical sounding that was conducted. And this is the laboratory geotechnical tests that were carried out. The greenhouse analysis test, Atterberg limits test, compaction test, the California bearing ratio test, the compression test, and lastly, the specific gravity test. This is the picture showing when I was carrying out the grain size analysis to determine the percentage of clay in the soil sample, because clay is a problematic soil for geotechnical works, and that is why it was being used to know the percentage of clay that passes through sieve number 200. So it will also help us to know the suitability or not of the soil samples for roadway construction. And the right is showing the sieves arranged in descending order from the coarsest at the top to the finest at the bottom. And the consistency limits in the course of this, liquid limit and plastic limit were determined. And the plasticity indices were used as the numerical difference between the liquid limit and plastic limits. Then compression test was also used to carry out to know at what point the soil fails and is known as the unconfined compressive strength of the soil, as being shown at the right side of the picture. The compaction test also entails determination of dry density and the corresponding moisture content of the soil samples. The graph is showing a parabolic curve of a graph with a plot of dry density against the moisture content. So the apex of the curve shows the maximum dry density. That's the density after which the soil begins to fail. California bearing ratio tests are of 2 stages, this unsoaked and the soaked. The soaked the difference is that the soaked were carried out after being immersed in water for about 48 hours, and the essence of this is to know the effect of water on the strength of the subgrade soil. The stabilizing agent entails the replacement of the soil sample with lime of 2%, 4, 6, 8, and 10%. And at the end of this, each of these tests, 4 tests indicated, are carried out to know their effects, to know the effects of the lime on the strength of the soil using each of these 4 parameters. And this is the electrical resistivity investigation results. This is the result generated using Schlumberger method. The vertical electrical sounding was used to generate this, and from this we can see that the major curve types is QH, and the implication of this is that there is a decreasing resistivity value which gets to a point and begins to rise, and typically indicated that the lower, especially within the first 5 to 10 meters from the ground surface, there is a less competent soil when compared with the one at the top. These are the vertical electrical sounding curves for traverses 1. As we can see from this, all the curve types are QH, and these are the 2D studio section generated using Wenner method. And from this to the depth of 10 meters, we can see that there is a similarity between traverses 1 and 3 of topsoil being underlain by incompetent soil, this is sandy clay and clay soil, then followed by pits and clay, which are not good enough for soils that are used for geotechnical purpose. There is a correlation that was done between the 2D studio section and geo-electric section of traverse 1 as it being indicated. Then these are the vertical electrical sounding for traverse 3. Out of the 4 curve types, only one of it is having curve HA. So as I said earlier, the majority of the curve types have QH. Then there's also a correlation between the 2D section and geo-electric section of traverse 3. This table is showing the classification properties of untreated lateritic soil sample. So from this table, you can see that the percentage passing through curve 200 of sample 5 only has percentage that is below 35%, which is the limit of the percentage has been recommended by Federal Ministry of Works and Housing for a good soil to be used as a subgrade soil for road construction. Other samples for sample 1 to 4 have percentage that are higher than 35%, and these are the curve types, the grain size distribution curve for the grain size analysis. And from the table shown, it's shown that, just like I said earlier, it's only for sample 5 that has percentage that is lower than the recommended value, the limit that was recommended by Federal Ministry of Works and Housing, which is 32.5%. So the others are above that, which suggests that could be one of the reasons why the road often fail. Then the plasticity chart also shows all the samples to fall within medium plasticity, which is of average plasticity value, and is also not really good enough for subgrade soil that will be good for road construction. Then the variation is unsoaked and soaked California bearing ratio test also show that all values for the soaked are far lower than those for the unsoaked. And the reason for this is that when water infiltrates soil, it reduces the strength of the soil. Now, the effect of lime as a stabilizing agent was investigated, and from these curves, using consistency limits, that's for liquid limit, plastic limit, and plasticity index, there is a general trend of decreasing liquid limit with high lime content, and also for maximum dry density and optimum moisture content, there is a general decrease in maximum dry density with corresponding increase in optimum moisture content. And for California bearing ratio, for both soaked and unsoaked, there is a general trend of increasing California bearing ratio values with increase in lime content. Now, the variation of unconfined compressive strength and cohesion also increases with increase in lime content in percentage of 2, 4, 6, 8, and 10%. From the table, the average percentage increase in CBRO and unconfined compressive strength are shown and indicated. Also, the average percentage reduction in consistency limit with lime percentage proportion are also indicated in the table. So the effect of stabilizing agent on subgrade strength was observed, and generally it's led to significant improvement in subgrade soil strength. So from the table, we can see that the effect of lime on California bearing ratio test, and both for the soaked and unsoaked, increased. Maximum dry density reduced, optimum moisture content increased, unconfined compressive strength generally increased, then the cohesion also generally increased, while the plasticity reduced. So in general terms, the effect of lime on the strength of the subgrade soil was found to significantly improve the strength of the soil using lime as stabilizer.